Hey everyone, this is Brett Davis coming to you live from my home office. I want to demonstrate the ease of which the DOLPHICAM2 is capable from jumping from material to material and varying thicknesses of the same material. There are about 4 to 5 different settings on the DOLPHICAM2 that you need to adjust and know how to make those adjustments. A couple of the ones that we're going to look at could be the number of firing elements or the gain controls, but in this case our primary ones will be the range and velocity. You may also want to adjust your color palettes, but let's take a look and show you guys what we can do with what we have. So thank you very much for watching us. Thanks for joining. If you guys have time, please leave your comments and questions below. And also, please feel free to like and subscribe to our YouTube channel at DOLPHITEC, as well as join us on LinkedIn and Twitter. Again, this is Brett Davis with DOLPHITEC, and we hope that you guys enjoy this and it's beneficial to your needs, and you guys can use the DOLPHICAM2 for your application. So we're going to get started right away. Here you can see that we have a 5 megahertz transducer. This transducer contains 128 by 128 active elements, so giving you 16,384 A scans. We're going to activate those in our time of flight. We're going to get started on a CFRP sample that is very thin. It's about a little bit over 3 millimeters thick. We're going to go to our velocity, go to CFRP, make that quick adjustment. As you can see, here's my front wall at 0. My back wall is gated at, my back wall is here at about 3 millimeters, and now we're ready to rock and roll. So we're going to slap a little more water on there, and as you can see, there's my back wall, exactly where I need it to be. And then as you can see, the back wall starts to shift. Here in the B scan, we start seeing the front wall or the back wall shift forward because there's some inserts inside of this panel. So that's the first sample. Again, now we're going to jump into another sample, which is another CFRP sample. This contains is another aerospace application. It does contain lightning strike mesh, as well as there is a paste bond in the back layer. So you guys are going to see some unique responses to this particular sample. It's not just clean cut samples. So this one's a little bit thicker, so we need to adjust our range. There's my back wall. There's that paste bond right there, and we're going to take a look and see what we can find. So this particular sample does have some impact damage. As you can clearly see here, the impact damage was created by the manufacturer and was used with a calibrated instrument. So much better than my samples that I try to fabricate here at home, which do not look good. So as you can see, as I adjust my front wall gate, then of course I can see different layers and different thicknesses of how deep that impact damage has affected this particular piece. And then according to your engineering requirements, you guys can make the proper repairs accordingly. So, okay, now we're going to move on to the next sample. This piece is a little bit thicker. This is off of the Boeing 787, and this is a Dreamliner, and this piece is a little bit thicker, as I mentioned. As you can see, again, I'm going to adjust my range. Because of the velocity, I don't have to adjust my velocity because CFRP, does vary, it does change, but not enough to make a difference here in this particular sample. Now, this one does have that lightning mesh, and there is a special coating at in the beginning is what I was advised. So we do get some beam scatter here in the front wall, and so I'm going to adjust my gate. It doesn't mean that I can't see what's going on in my B scan, but I do want to just show you guys real quick how easy it is to make some proper adjustments to screen and scan your samples. If you are doing an aircraft or any other composites, how easy it is for a technician to make some adjustments on the fly. You don't need 80 hours of training on our system. You don't need 40 hours of training. It really only takes about 1 day's worth of training. Most of our people are up and running within 30 minutes. So as you can see here, here's some more impact damage. You can see it clearly in the B scan. We can move our cursors around. It's very faint. You can see right here. I can adjust in my A scan to give you this a little bit better contrast. Let me adjust that, and there we go. So I do forget sometimes. When you do need to make some adjustments on your both A scan setup and the time of flight, and then we do have our 3D view as well that you can see. There's an impact damage right there and give you a little bit of characterization. And if we wanted to go back to this particular sample, which the impact damage looked much better, as you can see here. Now you can come in and make some adjustments and move this around so that way you can see clearly what the impact damage looks like. Rather than, could you imagine trying to do this with a single crystal A scan? You'd have to raster scan back and forth and collect and encode all that data to give you this view. But just because of our design or 2D matrix array, we can see exactly what's going on underneath there, and a technician can analyze and interpret exactly what they're looking at. See this shape and size of that damage. So we know it's less than the probe face, so therefore it's approximately around probably 3/4 of an inch wide. And if we wanted to, we could freeze it. We could go into our time of flight, and then we could measure. This is a little bit more, so 18, 19 millimeters. So, and you can measure any direction. Okay, so that's more than what I was planning on doing. But let's jump into the aluminum sample. I'm going to try to keep this short. Now this piece is about 18 millimeters thick, so I'm going to go ahead and make some adjustments. I need to go into velocity, go to aluminum. There we go. We'll go back into live mode. Make sure there's my back wall right there at 18 millimeters right here, and so we're good. Now we're going to go ahead and start scanning, and you can see the back wall starts to shift and change according to the step wedge that we're scanning here. So that's how quick and easy it is, folks, to make some adjustments on the fly. The reason why is because our TRMs are fully digital, so therefore it's giving us a little bit of flexibility. We can also measure. We're calibrated to, essentially calibrated, or normalized to the delay material. The delay line right here, we know exactly how long that sound path is, so therefore we can calibrate to that. And then when we go onto our material, we know the given material that we're inspecting, and we should know exactly where our start is, where the end is. So if it's 18 millimeters, 17 millimeters, then we know our back wall is appropriately there, and then we coordinate that to the other indications that are on that calibration block. Now we're going to jump into our Rexolite, do the same thing. Let's go to our thickest area. Let's make an adjustment to our all right. Now we can go to our range. Oops, forgot to turn off my measurement tools. There's my back wall echo, time of flight. There we go, clean it up nice and clean. So there's our back wall, there's our indications. My front wall gate is not set just right, so there we go. There we go. So as you can see, we can scan pretty quickly as well. Now that you do get a little waviness in there, because if you wanted to make that adjustment, then you can come in here, go to your signal averaging, turn that down a little bit, and then you can scan a little bit faster without that wavy, as you can see there. So, okay, and now to end it off, I know a lot of people always ask about metals, so this is a sample that I used in my last video. If you want to see and learn more about corrosion, you can go to my last video on our YouTube channel to learn more about that. But again, the intent of this video is to show you how quick and easy it is to adjust on the fly to different materials. So let's go to our velocity once again, and similar materials of different varying thicknesses. Stainless steel, and let's go to range. There we go. Here's my front wall echo, there's my back wall, let's clean it up. This one does have some corrosion in it, so as you can see, if you're watching your B scan right here, you will see some variations start to occur. Here's one. There we go. Oh, that's a nice one right there. So, perfect. All right. Well, we hope you guys enjoyed this. If you have any questions or comments, please feel free to take a moment and comment in the section below. Also, subscribe and like to our channel. And then, again, join us once again on Twitter, LinkedIn as well. So we appreciate your time. We hope you guys learned something today. hopefully the DOLPHICAM2 is a very good system for your application. And if you have any questions, you can email me at brett@dolphitech.com, or you can also go to our website, www.dolphitech.com, and go to our Contact Us page and to connect with one of the reps in your area. Or you can learn more about the DOLPHICAM at our portal page, portal.dolphitech.com. Okay, thank you very much for your time. We appreciate your time with us today. And again, please comment below. Let us know what your thoughts are. And take care. Have a great day and stay safe.